Yeah, today we'll basically talk about logistic regression. So let's just discuss what this is. So like in earlier, like an algorithm is there, right? So it will either be a classification algorithm, or like we were doing, it was like a prediction algorithm, like let's say linear regression, which we did. So classification algorithm, the first one we are going to do is something called the logistic regression. Okay. So what we are going to do in this, we are going to divide the whole thing in two classes. Let's say we have a positive class and a negative class. We denote the positive class by 1, 0 to be the another one. So in the earlier case, in the good old linear regression, we had a discrete valued y, right? So we are now going to change the form of our h theta x. So now h theta x will become g of theta tx, where this will become 1 by 1 plus e to the power minus theta x. So theta tx. So this will be the formula. So basically this g of y, let's say, is equal to nothing but 1 plus e to the power minus y. This is the formula of this. So this function has a very good name. This is called the sigmoid function. This is called the sigmoid function. Okay. So, or you can call it the logistic function as well, coming from the logistic regression thing. So if you plot this ever, so if you plot this, it kinda looks like this. So let's say from the value of like this. Look, yeah, wait, I drew it so bad. Wait, I will be a better artist. I guess something like this. This is exactly in the middle, by the way. So sigmoid kind of looks like this only. Okay. So now, um, since we have that updatation, the loss, we need to find out the loss this time. We need to find out what the derivative of this function will be, right? So let's try to find out where, let's say, gz is. So gz was 1 by minus e to the power z. So we now have to find g dash of z. How do we find out g dash of z? It will be nothing but, yeah, not partial derivative, sorry, d by dz 1 by e to the power minus z, right? So this will become 1 by e to the power minus z whole square into e to the power minus z. Now I think, yeah, you can write it something like this now. No, 1 plus e to the power minus z is equal to 1 plus e to the power minus z minus 1 by 1 plus e to the power minus z. Okay. So this will become 1 by 1 plus e to the power minus z, and this will become 1 minus 1 by e to the power 1 plus e to the power minus z. Okay. So as we can say, this will become nothing but, this term is nothing but what? This is g of z and this is also g of z, right? So we can write g of z into 1 minus g of z. So this becomes my derivative. Something we'll be using later on. Okay. So now since we have two outputs, right? So we have two outputs. Let's say the y output will be either 0 or 1, right? So basically, how are we going to use this logistic regression model for classification? Let's say we have 0 and 1 as the only output. So let's say we name p of y equal to 1 such that x theta will be, let's say, h of theta x. Okay. And then p of y equal to 0 x theta is equal to h theta x. Sorry, what the fuck am I even writing? Sorry. So 1 minus h theta x. So basically, why does this happen? Because we have only two cases, right? So let's say if one thing has a probability of p and the total probability is 1, so the other thing will have a probability of 1 minus p. So this is the simple logic. Okay. So now, yeah, so now there are two cases, right? So let's say you're doing this thing, the probability of y such that x theta. So now, since there are two cases, doesn't it sound like a binomial case? So let's say the total number of cases. Yeah, so basically I think we can write it something like this, right? So since it's in the case of two cases or binomial cases, we can like write the probability as h of theta of x into, let's say, some value y into 1 minus h of theta of x 1 minus y. I think this is diagonal from binomial. If you want to see how binomial works, you can check the probability videos. So now the loss function, right? So the loss function will be some just the product of all of this, I guess. So the product of p of yx theta, right? So I'm not writing this, but it will be I is equal to 1 to, let's say there are m samples, right? So this is the loss. So like we learned log likelihood. So wait, let me write L. So log likelihood of theta will be what? Log of, what will it be? Log of L theta. So this will nothing be summation of yi log h theta xi plus 1 minus yi log of 1 minus h theta xi, right? Let me just shift this a bit this side. Yeah, okay, this is the L theta, and let's try to maximize this. So if you remember, in the case of linear regression as well, we were trying to maximize this. So how do I maximize this? We have to first do the derivative with respect to, let's say, theta j. So how do I get this? Let's get it. Yeah, yeah, okay. So yeah, I think we can look at this as g of theta tx, and this as also g of theta tx, right? I think then we can substitute the values well. If you do the derivative, it will come out to be something like y 1 by g of theta tx minus 1 minus y g of, yeah, not g of it. So it will be 1 by 1 minus g of theta dx. Yeah, this whole thing into d by d theta j of g theta tx, right? Okay. So now this thing is something we calculated, right? This thing is something we calculated earlier. The thing is nothing but the g of, yeah, this thing, g of z 1 by gz. Okay, so let's use this formula, I guess, here. So this thing, this part is copy pasted, no changes. So but this thing will become g of theta tx into 1 by g of theta tx into d by d theta j into theta tx. Okay, okay, now we have to just basically multiply this. See, if you multiply this with this, g theta x will get cancelled. If you multiply this with this will get cancelled, right? So let's write this. So here it will be y into 1 minus g of theta tx minus 1 minus y of g theta tx. Okay, and this will be just xj. I hope you remember why this will be xj, because all the other cases it will be a constant. In the case of xj only, the theta j will be cancelled, so it's basically theta j xj. So xj is constant, get it out, so it becomes xj d of theta j by d of theta j. So this is nothing but 1, so we get x of j. Okay, so this becomes, if you calculate, let me calculate this. Okay, so it will be y minus y g of theta t x minus g of theta t x plus y of g of, sorry, y g of theta t x, right, into xj. So this and this gets cancelled, so this becomes y minus g of theta t x xj. I think this is the formula. Yeah, so this is the this thing. So basically we remember that the gradient descent updatation works like this. In this case, alpha of dl theta by d theta j. So like you can just update it here. Okay, so you can just update with respect to this. So this is all about logistic regression. This is how it's basically linear regression. We use the everything related to linear regression, nothing different, just this h, you have to remember just this formula. Wait, why did it type almighty? Just this, wait, let me do, yeah, so why can't I write, yeah, why is it typing almighty? What is happening? Even I have no idea. Wait, give me a second. Yeah, so basically everything in this is the only different thing. So if you have learned linear regression, right, so linear regression, you have done linear regression, just you have to, what do you have to do, you have to just change this h of theta of x into linear regression, and what do you get? You get logistic regression. So this is all about this.